Dorian, thank you so much for your time. We're super excited to demo our stuff for you.
Absolutely. I'm psyched, man. I've been waiting for this for a long time.
All right. And just as a reminder, we are Launch It Labs. We've been working on this stuff for many years. Started by creating a backend framework for like high performance scalable backends, and then just jumped on AI and figured out how to leverage a lot of the stuff we have built with AI and GPTs, and really excited about what we've come up with. So I'm going to share my screen. Cool. This is Livy. And Livy would like to know what game you would like to build today. I'm going to go with tic-tac-toe. And the first thing Livy does is it pumps out some use cases. Start a new game, join an existing game, make a move, game over. Those are great use cases. I'm going to add matchmaking. We can have this is essentially a leaderboard, so let's add that. And let's go to the next step. And as the next step, it has now, well, here's basically, it's created a system overview. So it says, okay, you wanted to start a new game, join an existing game, make a move, game over. We're going to put that in our game management system. We're going to also have a matchmaking system, also have a leaderboard system. And then it started to come in and actually architect these systems. We have sequence diagrams, class diagrams, and basically we're leveraging our framework here, which is an actor system where actors are high performance, they run on the server, and our technology syncs them down to the client. So yeah, that's kind of the first thing we've done now is we've designed it, we've architected it, and we're ready to generate some code. Do you have any questions on any of that?
Yeah, so just as far as like the sequence diagrams that I'm seeing, those are derived from the main use cases it decided you needed, right?
Yeah, first we started with use cases, and then we went down to a system overview where it paired those use cases into systems. And the idea with systems is these are basically, you can isolate these things and build them. And that allows us to basically scale out and have tons and tons of features without, overloading the GPT context. And then for each system, it will go in and actually architect that system.
So like a system is like an archetype you have predefined, and the model can assemble the systems based on your needs?
Yes, absolutely.
Awesome. And then for the sequence diagrams, like, does the model create the sequence diagrams from scratch, or are they pre-built for a system?
They are created from scratch.
Okay.
Given what that system, all of the actors, all of the interactions, the requirements for that system.
Got it. So the model has some idea of the details in the system and can tweak it or customize it to what you're asking for?
Yeah, I mean, it knows a couple of things. One, it knows what all of the use cases that system has to accomplish, and two, it knows about our core technology and the fact that it's an actor framework, the fact that actors message each other. It doesn't worry about how does networking work, how do we get scale, how does the clustering work, because the framework handles that. So it can talk very high level, and then it can design out its sequences and its class diagrams.
How are the sequence diagrams expressed? Is it like a domain specific language, or is it actual code? Like, how did it actually write those?
Well, we have our own intermediate format that basically that describes the architecture. And it's a format that we know how to generate code out of.
That's awesome.
So we actually just generated that, and then we derive what we need to render diagrams.
That's awesome. Yeah, having that power of like the DSL that sort of expresses framework concepts, and the model can then think in terms of DSL, which is way simpler, rather than having to reason about a Turing complete language and all the ways you could solve. Yeah, I think that's the right way to do these kind of complicated problems. It's also how like other platforms like Palantir are enabling the LLMs to use their platform. Same exact concept. They create this DSL, the model learns how to work and assemble the DSL to express like complicated concepts in this case like systems. So that's awesome, dude. Really cool.
Cool.
All right, let's go on. So we're moving from architecture to code, right?
Yeah, code gen.
All right, cool.
Perfect. All right, so I'm going to take you through what Livy is capable of doing when it comes to generating code and generating a real project that someone can use. So the first steps, like Iman said, was to generate the architecture that works with our framework. And the next step is to generate the code using that framework. Code generation using our framework is a lot easier and simpler than if you were to just ask a ChatGPT interface to generate a backend, because you can get a lot of dependencies and there's a lot of questions that need to be answered. Whereas a framework makes it very clear what code needs to be generated. And we follow a very specific order of operations to make that easy. So this all happens pretty much autonomously. Once you've okayed the system design, the features, you can generate the code without much human interaction at all. First, it generates all the messages necessary to send between components of the system. It creates all the outlines for the code it needs to create. And then it begins to iterate on the actual classes themselves, the components. This follows several steps of compilation, verification, and most importantly, testing. So the AI is really good at making first passes on all of the components you need. And it does a pretty good job of getting the game logic in there, but sometimes it makes mistakes. Sometimes it hallucinates. Sometimes it forgets things, which is totally natural. So once it takes a nice first stab at getting everything created, it then creates a test plan for every single component. So it will generate multiple tests to hit different angles, different aspects of the code. And it will create those tests, run them, and make the appropriate decision based on the outcome.
So if we could unpack a couple of things in there. One, I think it's really important to understand this concept of layering that you're doing, where you're starting with architecture, but then as you go to build the code, you're layering in levels of complexity. So it's like you're having it outline the components, you're having it write the tests, but the process of doing all of this is sort of enriching the context window, so that the model has a better understanding of what it needs to do. Are you also like bifurcating and splitting things out into individual tasks that then leave the main context window and become like separate? Yeah.
Absolutely. So what we want to do is we want to give the AI the best context we can. And so anything that's not relevant to that particular system, we try to remove that from the context. So rather than kind of giving every single component the same context, what we do is we, knowing our framework allows you to really silo development of features really effectively.
Nice.
And so in doing so, it allows us to take the relevant parts of the overall system design and specifically feed those in. So you get a really tight context and then a very specific task. And so, the way that you format the code in our framework is very regimented as well. So you have a very small context, explicit task, and then really rigid output format.
That's
and
awesome.
The combination of those three things, perfect for AI. So it does a really good job. And that applies to both the classes you're creating and the unit tests for those classes. They also follow a very strict procedure. So it does make it quite effective. That being said, the AI will always make mistakes, and that's okay. So if the AI makes a mistake, or let's just say a test fails. At that point, if a test fails, we need to make a decision. Do we fix the test because it was a problem with the test, or do we fix the class because it's a problem in the class? So at that point, you really need the AI to kind of take on multiple roles and look at it from multiple angles to come to a single decision of what's the next step.
That's awesome.
It won't always get that right either, but it will
Right.
iterate and iterate and iterate, and it's capable of basically fixing itself. And so it does a really good job of eventually converging,
Nice.
where you have completed tests, completed code, and you have a really solid foundation on which to start your
Before we
project.
move on to like the problem, like getting to a steady state with the test and the code, like this approach you've taken where you have one agent that'll do evaluate, like I'm gonna call it an agent because like the way we've been approaching it is a multi-agent framework where like one agent's responsible for this task of like generation, another one might be doing grading and evaluation, might have another one then that looks for deployment and execution, like, but we're dividing up all these roles and we're letting these agents kind of reason among themselves to get to the goal, which is in this case is like a running game. Would you kind of describe it that way too? It's like a multi-agent framework where each agent has a role and they're working together.
Yeah, absolutely. There are several roles. And so at the, depending on what stage you're at, and also when you're evaluating a test, right? Especially when you're evaluating a test, that's when you need to say, we need to look at this from multiple angles because we need the help. So it's probably 5 or 6 prompts that need to get evaluated.
And can you unpack the work you had to do to actually run the code? Because there's a lot of innovation that has to happen just in this space where like you take the results, but you still got to figure out how to run it. You got to like execute it. You got to unpack the results that are coming back from the compiler, the testing outcomes. Like, what did you guys do when you approached that problem to give it a runtime and an environment to work in?
Yeah, that's a really good question, and it also is a good example of why our framework is so powerful here. Since we know exactly how all the classes are going to be formatted, how they're going to operate, we create outlines with stub functions for every single class. That alone will compile. It won't pass any tests, but it will compile. And so we can use the project of outlines, and then we swap in the classes as we are developing the code and getting it to work. We develop it. So in isolation, we'll develop one particular class, but we'll compile it against all of the outlines. And we make sure as part of the verification step, like we said, there's multi-roles, right? Certain things are looking to verify that that class that you're generating complies with the outline. Right. So since every class you generate has to comply with the outline, you get you basically always have a compiling project unless the class you're working on fails, and then you have.
But you had to lay a lot of infrastructure work to do that, right? Like you would need the equivalent of like a replit environment where it's like you've got to be passing code, right? You're writing code somewhere. You then have to integrate a compiler to try and compile the code. And then you're actually like building a test harness and like,
So we basically spin up a whole new project for it, right? It gets to work, separately in its own class. Absolutely. It has to link in the appropriate libraries to make sure it can run with just the classes. So absolutely. Yeah. We're building every single time the AI is changing a class. It's working its own
set,
it's working its own.
I mean, a lot of the people I know right now are struggling just to do that, like just to provide the tools for an agent to actually be able to like write code, evaluate code, run code. Like that's actually really hard to do. So that's awesome.
Yeah. So once it starts evaluating the code in here, and you say it has a compiler error, right? Then that's when we look at the logs, we pull the error out, and we basically have a system of prompts in order to give the error back to the AI with the appropriate new context, the code that it created. And it's very, very good at fixing compiler errors.
That is awesome. All right, let's unpack that real quick. I just want to summarize it. This is totally organic, by the way. We haven't practiced this, so I don't think we're like running off a script. But like to me, it's important to understand it. We've got and a controller that can do architecture, a controller that can understand the tasks that need to be completed. We've got agents the controller can rely on to perform things like building stubs, writing tests, evaluating the tests, writing code. And underneath the hood, there's all these tools that those agents can use to compile code, look at compiler errors, rewrite code, rerun code, run tests, rewrite tests, like all of that, all of the low-level tools that need to be combined within that agent to allow it to achieve its goal, basically. That's awesome, dude. I think it's incredible to have put that together, especially in this short of amount of time. How good is it at getting to a point consistently right now where you can get to a passing test for all classes, or do we still want to focus? Like, I think I know the answer to this, but like, is there still are we gonna get to a point where we still need a developer to come in and fix things that can't be fixed by the machine?
Yeah, so right now I have the example up where we go all the way through a project.
Yep.
And at the end, we're ready to deploy.
That's amazing.
So it's ready, you know, it will export. In this case, this will export a Unity project that compiles, that has all the tests with it, a functioning project.
I would take a step back. I just want people to understand this is a developer tool, right? We're focusing on this for the use of game developers, specifically right now in the Unity space, but expanding to other frameworks. The interesting thing that we can, the way this runs right now is like it's essentially able to affect the same file system that the developer is using in their IDE. We're not showing that right now, but like that's essentially what's happening under the hood, right? Like where the files are being written is the same place the developer can then access them.
Yeah, so the exciting news is we actually support Godot as well.
Oh, wow. That's awesome.
Yeah, and we're really excited about that. Because I think it's really going to open up kind of what services we're going to be able to provide to people, given that we don't have to comply with rules about creating editors and doing build jobs for other people and that kind of thing. So it's
especially really now, right? Like as people look for alternatives to Unity and they're pushing over, this could be like the perfect time to converge with that wave of developers.
Exactly. And so what actually is happening is it's going along is it's creating all of these different environments. So every single time it's messing with the code, it's creating a new environment. And that way you can kind of go in and you can kind of see what it was doing at that point, and you can make changes to that point. At the end here, when you click deploy, that's when it actually will set up the full project for you. That's when it gives you the editable, like developer ready, all the tests are in place and running in green. You're good to go.
That's so cool. Yeah. Iman, I think you wanted to jump in there.
Yeah, a couple of notes. One is we recently learned that Unreal has a C# runtime, which puts them in play as well. Potentially, we got to run some proof of concepts there. But what we're seeing with AI is the actual tool set you pick. I think it becomes a little less important, and it's certainly not important to be an expert, right? Because when we export this project, anybody is going to be able to jump in there and do what they need to do, whether it's Unreal, Unity, or Godot, because it's a working project, fully documented, tons of tests, right? That's really what's important. So I think the past era of software development, we've seen people become really good at a tool set and then just want to knock everything out with that tool set. And they're not thinking about licenses necessarily. They're not thinking about, is this the perfect tool for the job? But we have a very easy time kind of once we get the core concepts down, switching between different platforms because it's all automated.
That's a great point. I think that's what we should unpack for one second, because it's like the fact you have a DSL and that earlier portion we saw with the architectural design, that's all agnostic as to any implementation. Like none of that is relevant. Like it could be any other language that you're spitting out after that. And even the tech you've invested in right now for that is doing the multi-agent negotiation of like how it's going to build the game. Yes, the code being implemented might be in a specific language, but that process, the iteration that you've created, would be tech agnostic. So if you wanted to program in C, for example, or something, you would just build new simple implementation, like basically a new tool that's just spitting the code out in a different language, a new tool that lets you compile for a different compiler. And that's like actually a relatively quick process. You're not reinventing the whole tool chain. You're
Yeah.
just swapping the tools that the,
Yeah.
that the agent was then using. That's freaking
Yeah.
amazing.
The easiest thing in the world for AI is to take a DSL and export it to a different target.
Exactly. That is so cool, man. Love it. Yeah, this is perfect timing too, especially with what happened with Unity and like looking at developers who are looking for alternatives. To then not only give them an alternative that can do what the lower level framework can do with the messaging and being able to build multiplayer games, but then this AI layer on top to do it like extremely quickly is huge. Awesome. So can you actually deploy this?
Yeah. So this is it basically right now it creates a completely functioning Unity project. And what's awesome here is you have all of your tests that are passing. Cool. You have all of your code where it needs to be, and you're absolutely ready to deploy the server.
What does the developer have to do to just do that last mile UI work by hooking it up to the server objects you created? Is it just adding the graphical assets, wiring them up in Unity to work with the server object so that it can reflect the data that the server object, the state the server object is in?
Yeah, so right now our framework is full stack reactive. And so anything in the backend that your user has access to is basically right up available to the UI. And when you bind to that, you're going to get all the change events. It's going to be up to date.
Perfect.
At high
so they just
speed.
have to wire in and within Unity get their graphical assets reflecting the state of the server object, which is sort of just that last mile. And so people to understand like what the framework does, what game plumbing framework does, and or Launch It Labs does now is they keep, if you have a multiplayer game, you got to reflect the state of the game for all players, right? And that's actually a really hard problem. There's a lot that goes on under the hood, and you guys have amazing throughput with that, right? Like I forgot what you went from originally. I think it was like 100 messages a second to like 1,000. And that's a hard problem, right? So like as a game developer, that's why so many games are single player initially, is that getting that multiplayer aspect and the connectivity so that all that state can be reflected among all the players. That's like actually hard. So and so what was generated here is that connected layer, right? It's got all the game objects that allow those players to join a lobby. It allows them to play the same game and have that state reflected among all the players. What's missing is just that last mile of like attaching to the UI all the game graphics and objects that will then reflect that state, right?
One thing I'd like to highlight before we start is the code that the AI generated is in the server objects folder. So this is code that is going to run in the client and on the back end. This is what allows for kind of a high-speed reflection of the state, and it also allows for you to run local simulations, local debugging inside the testing framework. We also have other tools to help with debugging. For example, what we call Data Store Explorer. As a reactive framework, in the client, on the client side, we have a data store where all of the variables that you are synced to on the back end are kept up to date. And this is kind of like a universal translator tool where you can have UI elements. Maybe you want to display, maybe you have a UI element that's like a speedometer gauge,
right?
And you can bind to a value. You might have a text element and you can bind to a value. And the data store will actually do the type conversions for you. So it doesn't matter if the value is a string that is a number, right? It'll do that. It'll pump out the right values so that it makes developing your UI really easy. And we can kind of search through
it's like automatic type coercion, that kind of thing. That's cool.
Yeah, and so we can actually search through in the Data Store Explorer what the current state of the game is. So if you're playing, you might not have all the UI elements ready in your game. right? Maybe not everything's hooked to the UI. Maybe you have data deep in there and you're like, what's the value? And so with Data Store Explorer, you can kind of open it up and see, hey, what are all these values? Maybe I don't have UI hooked to them, but I really want to know the value. And so we have a way of looking through those. And right now what we're seeing is it's the autocomplete interface, but we're seeing what values are available and what types they have. And what that means, and I can build a UI really quickly, I guess. I wasn't expecting that, but I'm not against it. I'm not opposed. So let's create, say, a let's look at a button, I guess. Buttons are nice. Where's text? Excuse me. Let's see. What I'm going to do is I'm going to add a view binding. This is a pre-made example view binding that we ship. Sources available as well. So for editing and creating your own view bindings, it's really easy. But what this view binding allows us to do is take is select what data we want this element to display. And so we have an autocomplete interface where you can search through to find the pieces.
All those properties are on the server objects that the AI generated from your game description, right?
Absolutely. Yeah, and so you have access to like the state. Basically, you can use the autocomplete to know for a fact. So if you had gibberish in here, right, it's going to flag that and say, hey, this isn't actually data. And then once you have everything set up, you can go to the project settings, and you have a few different options as far as like how you want the game to run. We do have a simulated backend that does work for single player. So if you do want a single player game, that is possible. It will just run just fine. But we also have an extremely easy way to launch backend. So if you have AWS, we have a really great AWS implementation. It's Dockerized. You can use whatever hardware you'd like. We just happen to have a really slick, easy to use AWS implementation. So you can just deploy new. You can select region, stack name.
So in the future version of the business, like I think that yes, we want to have the ability to deploy directly to a customer's infrastructure. And that might be AWS, that might be GCP, but from an individual game developer point of view, like if we are the ideal for them might be like just to use your existing infrastructure, right? So like if they the vision is instead of this panel, they'd be using another one that like they create an account, whatever tier they're going to accept, and then when you deploy, it just goes into Launchit Labs infrastructure, right?
Absolutely. And that's what we'd love is for someone not to have to really open up Unity at all. That might not work with Unity, but with Godot, we might be able to, because of licensing. With Godot, the ideal situation would be from the Livy chat interface, you're able to build, it can give you interactive examples where you're like, yes, this is what I want. You can deploy on our infrastructure. And so without ever having to open up a game engine, just on your own creativity, you're able to create a game that's fully multiplayer.
Totally.
Yeah,
that's awesome. That's awesome. And just so we're clear, like people watching this, so that they would understand if someone watches the recording, the server objects get deployed to a hyperscaler typically And that way they're available as a back-end technology to all these games that people are playing, and it can scale out to meet demand. It can take advantage of the auto-scaling capabilities there. And what that enables is like, if you have a successful game, you're more than capable of scaling with that game as it becomes successful in the market, and you're getting like millions of players. This solution will scale out to meet that demand. That's awesome.
Yeah, exactly.
Awesome.
So this might take a sec,
okay.
But we don't have to wait. We don't have to wait for Amazon's servers to be.
Yeah. Complete. So what's happening in the background is like you're executing like CloudFormation templates that are spinning up the infrastructure, provisioning everything, getting it ready so that, yep, that's awesome.
Exactly. That's awesome. Exactly what's happening. So yeah, we don't have to wait for that, but it's very low dev time, right? Just a few clicks of a button. But we'd love to have that happening again.
Well, I mean, one can easily envision this going into an online platform. So if I think of a platform like Vercel, which has become really popular for React developers as a way to bypass the need to have to write a lot of infrastructure as code and like deploy traditionally onto the hyperscaler and dealing with all that, you could easily envision this whole setup that we're seeing in Unity, like it just becomes an editing platform that is deploying to your own infrastructure that obfuscates all of that from the developer, and they don't need to worry about it. They just like literally come in, use an AI to get 95% of the way there on the game, tweak a few things, and work on their front end layer to build the visuals and the UI that they want. Hit deploy, and it's ready. Like you've just, I mean, you think about the amount of time that traditionally goes into that infrastructure component of a gaming company. It's insane. And I think the parallel is the same with Vercel and why it's done so well is like that whole infrastructure layer that you typically needed a platform engineering team to provide. That includes like the service catalog of how things get deployed, also the hard like low level infrastructure API orchestration and messaging and all those like really hard parts of building apps. Vercel's like obfuscated all of that effectively for you, you know. And I think that's what we're seeing here is like this would be the equivalent at exactly the right time when people are looking for like an alternative to some of these other platforms. So yeah, it's awesome.
Exactly.
Love it. Really cool stuff. Yeah, like back to the chat interface. I'm interested to think about how that deploy step, like so like when we were looking at the chat, you have that little deploy package. The vision is you just click that and this whole thing gets deployed out, right? Like there's none of that having to go into Unity and actually configure, like do the AWS deploy steps. In this case, it would just like if we click that, it goes out to Launch It Labs and like provisions everything.
Exactly. The reason that the person had to, or the reason in Unity you'd have to do steps is because you need to select your, profile to make sure they're deployed on your cloud and have settings with relation to that. But yeah, exactly. If it's on our infrastructure, we know those values already.
Exactly.
And, it can be one button for the.
Exactly. And then we can charge people for it, right?
Of course. It'll be basically, you'll need to pay for the users that you have, obviously.
Yep.
But yeah.
What's interesting too is to think about like one of the things that has been cool about Vercel is it's dropped a lot of the barrier to entry for developers. And so if you're like, you're not a 10x developer, right? Like I'm not a 10x developer. Most people aren't 10x developers. I know you guys are, but the average company that is dealing with people who are the average developer, like when you start giving them these tools, they can become just way more productive, right? So it's like you don't need to be the person that works at Netflix. You can be the person that works, wherever, but then you get this like amazing boost, right? And so you're able to produce, and also you don't have to solve those sort of like harder problems around, like, for example, with your framework, it's messaging. With Vercel, it's their ability to do the personalization layer inside middleware, and like they build an edge network to like make your app react faster, which is a lot of what the infrastructure component you built does. So I think it's one of those things where it's not a replacement necessarily of a software engineer, but it is a major boost to the productivity and also to the skill level, right? Like they can do now if you're like, hey, I want a multiplayer game that can scale to millions of users, go build it. They can actually do it, right?
Mm-hmm.
Pretty cool.
Yeah,
absolutely.
Go ahead, Sam, please.
I just wanted to point out that yes, it's a boost for the average developer, but it's also a boost for the superstar developer. Like these tools make everyone 10x, 100x better.
That's cool. That's awesome.
I think a lot of what we do is automating our expertise, right? Like if you look at our prompts, we were very lucky. We had a customer that let us essentially hire a team, and maybe not the most experienced people in the world, but they were passionate, and we taught them our framework. We taught them how to write tests. We taught them our processes, and it was really fulfilling, but that's not scalable. But the cool thing was we were able to think back to those conversations, and that influenced our prompts. So, we used to ask developers, did you write the test? Did it pass? Can we see it? Can we see the logs? Look at the log, look at the test. And now we've automated that, right? So all of these, one thing I learned about AI, it's not magic in that you just say, build me something and it builds it, right? It is
definitely not.
It's death by 1,000 cuts, right? We are doing 1,000 very small transactions that nobody ever sees, where you get the way I think software should be built, the way Dan thinks software should be built, the way Sam thinks software should be built. And it is influencing things. And the cool thing is, when you have a framework, when you already have so much knowns, and you already have a set way that things should be done, then all of this becomes much more straightforward. So the interesting thing is, we started with ChatGPT 3.5, not 4, right? Nowhere near as smart as 4. Nowhere near as smart as 4. But what you have to do is you have to not be very imaginative. Your contexts have to be straight to the point, and you have to ask it for things that are very doable. And the cool thing, having done that, the cool thing about that is you have a high probability of not getting that hallucination, that error rate, right? When you have huge context, when you're kind of pie in the sky, you might say, oh my gosh, look at how cool this is. But if you have to take something to production, you notice a delta, right? You notice that wasn't something that I can make money off of. But when you shrink in your context, and you're just inserting expertise through thousands of prompts as opposed to like one mega prompt, now you have high confidence, right? And you have these feedback mechanisms.
You can build a chain, and
exactly. So that's kind of where we've seen a lot of things that have impressed us, right? Like, we're working with this stuff, we're blown away, not so much by what we've done, but by the power that is unleashed when you take a framework, experts at building something, and chat GPTs.
I think it's that common, and that's across everything I'm working on as well, is like that concept of codifying expertise. That's what's going to win the day, right? And the way you do that isn't intuitive to most people. They're not exactly sure how would I go about codifying expertise. For me, it's a combination of both the prompts, which is like sort of the encapsulation of the knowledge, but also the algorithms. And so like the tools that provide the algorithms that the model needs, because you get both the algorithms provide the 100% accurate computation that the thing needs to do, whether that's generating code or whether that's performing calculations or doing physics or whatever the model needs. You need a tool for it to be able to do that. But then the codifying the expertise is like the knowledge of like how to put those tools together to achieve an outcome, and how does that and what are the paths that are valuable to a human in that space. All that work you're doing in the prompting, and all that work you're doing in building the process flow that this thing flows along, the guardrails, that's the IP, that's the codification of the expertise that you have as developers. What's cool is also learning, because like Dan explained earlier, it's like the developer who's in the loop here is also contributing to that, and it's going to adapt to them over time through that feedback loop you created, through the bug reporting, through the bug resolution process, so that the model will be adaptive to their coding styles and like know how to resolve their issues quicker the next time around. I think all that's correct, and it is, I think, like I'm working on other use cases right now that are completely unrelated to gaming, but are being solved by that exact same approach, which is really cool. That's awesome, man. Yeah. Awesome. All right, guys.
All right. Have a great weekend.
Cheers.
Thank you.
Bye.
Thanks, Dorian. Bye.
Bye.